Upwards. A particle is projected with speed 10 meters per second from the foot of an inclined plane with mass which makes an angle of 30 degrees to the horizontal. Find the range of cases where alpha, the angle which the line of projection makes with the horizontal. Alright, let's read the language really quickly. Range of cases where alpha, the alpha which the line of projection makes with the horizontal. Good. Alright. Interesting one this, alright? Is it not? Is this a really short question? Like a ridiculously short question. So it's 30 degrees, yeah? So I'm reading that it's 30 degrees with the horizontal, which is the angle of the thing. Then it says, find the range of cases where angle alpha, which is the thrown angle, yeah? The angle which the line of projection makes the horizontal is 75 degrees. Angle with where the line of projection. That does not 45 degrees then. And they had to give you 75. That's the answer in the back? What? Where does it say that? Oh, to find the range in the cases. Ah. I read it as range of values of alpha. So we gotta get the range of that, yeah? And it's just 45 degrees for the thrown angle, is that right? So we're gonna go for Vx, and so in this case it's gonna be 10. It's gonna be a thrown angle of 45, so it's gonna be 10 root 2 and 10 root 2. Is that okay with you guys? 10 cos 45 and 10 sine 45. Oh, sorry, 10 over root 2, my fault. So 10 cos 45 is 10 over root 2, and 10 sine 45 is 10 over root 2. Double check that. So far, so good? You aren't sure? 10 cos 45. 5 root 2 is the same thing, actually. So if I did 10 divided by root 2, the answer is also 5 root 2. So actually both answers are correct, but being honest, 5 root 2 is a bit tidier, isn't it? No fraction, so we'll go with 5 root 2. Now, so we're going to go for Vx, which is going to be 5 root 2 minus gt. So minus, let's just leave g as g for the time being. Okay, Vy, which is also 5 root 2. Actually, wait a minute, not gt. I digress. I haven't done the gravity triangle yet, have I? So I need to do that gravity triangle really quickly. Now, the hypotenuse is g. That's 90 degrees. The angle is 30. So we need to know what g cos 30 is. So anyone know what g cos 30 is? Root 3 over 2 g. Okay. Does anyone know what g sine theta is? Huh? Half g. Alright, so we're going down and to the left. Is that okay with you guys? Now, let's keep going. So we're going to have Vx equals 5 root 2 divided, take away a half g t. Vy is going to minus 3 root 3 over 2 dt. Sx is 5 root 2 t minus then half that, so it's going to be a quarter gt squared. Then do the next one. 5 root 2 t, half root 3 over 2 to get root 3 over 4 squared. Right. Nextly, range. What does range mean? Sy equals 0 and find your Sx, okay? So Sy equals 0 and this means that 5 root 2t equals root 3 over 4 gt squared. Cancel t equals 0, that's that answer gone. And then we're going to end up with 20 root 2 over root 3g. Just leave it like that if you want, okay? Next we're going to go for Sx formula here. And when I get to Sx, do it over here. So I'm going to enter that time of flight into the Sx formula. And what we get is 5 root 2t, 20 root 2 over root 3g. And then minus a quarter gt squared. Now I'm going to square that right now. So I'm going to square 20 root 2 over root 3. I'm going to square that out. There's my answer. Square it. 800 over 3. So that's going to be 800 over 3 g squared on the bottom. Alright. You know what? I suppose it's time just to turn the g's into 9.8s and work it out really. So we're going to have 5 times 20, which is 100. 100 times 2 is going to be 200 on top. Root 3 on the bottom. And a 9.8 here. Then we're going to have a quarter. I suppose that g cancels with that. So it's going to be a quarter of 800 over 3 times 9.8. We're going to lob all of that into the calculator. And we got an answer for it. Okay, let's do it out. So, yeah. Alright, I'll just get somebody to verify that. And if somebody else gets exactly the same answer, we're gold. You can share now anyway. What's the back of the book say? Yeah. Thanks, buddy. 4.98 rounds it off. Yep, no bad. How about cool with that? Alright. Now, Brian, we're going to go back to the very beginning. And oddly enough, we're going to follow nearly exactly the same routine, okay? So I'm just going to get rid of all this for a second. Now, good news is we have a lot of the work already done for the next part. The next part requires a thrown angle of 60 degrees to the horizontal. So the key thing in the language was it wants you to find the range, and it wants the line of projection makes it the horizontal. That's why we got 45 plus the 30 to give me the 75. This time it's going to be a thrown angle of 30 degrees, like so. Now, the only thing the 30 affects is it affects the U values up here. So if I change all this to 30, and what's 30? 30 is, so we need 10 cos theta, 10 cos 30, 5 root 3, and that will be 5. So phi x is now 5 root 3, and phi y is now 5. So if we want to make this really lazy here, I can just go back here, and I'll just change that into 5 root 3, change that into 5. That's 5 root 3. That changes to 5. Oh, I'll do that while I'm at it. Alright, so you're now 5 root 3, you're now 5, you're 5 root 3, and you are 5. Follow exactly the same routine you did last time. where you're going to find a t time of flight equals 0. You're then going to get 5t equals root 3 over 4 gt squared. T's cancel. You're going to get time of flight equals 20 over root 3g. Done. Lob it into Sx. Sx is going to be 5 root 3 times 20 over root 3g. And then minus a quarter gt squared. I'm going to square this out. And I'm just going to get 400 over 3 g squared. Alrighty. Let's see what I can do here. Root 3's cancel. And I'm going to be left with 100 over g, and g is 9.8. I'm going to be left with a quarter. That g cancels with that g. Now, I'm going to be left with a quarter times 400. 3 times 9.8. Lob all that into the calculator, and what you get? 6.8. Alright, cool. Done. And you're done.